Hi students, in this video we'll see how to minimize a given FSM. Right, so here a DFA is given and we'll see how to minimize the given DFA. Minimizing the given DFSM. Right, a deterministic finite state machine, otherwise I can say as DFA, deterministic finite automata. Right. So as the first step, I have to segregate my final states and non-final states. Right. So here I have two final states. I have to minimize this given DFA. The first step is I have to separate my final states and non-final states. You know, states with double circles are final states. States with double circle are final state. So I'll be writing my initial classes. Right. So this classes I can write inside my square bracket. Right. So initial class will be, first class will be final states and next one will be non-final states. So states with double circle, I have 2 and 4. So 2 and 4 in one class, and the next class will be all my non-final states, that is 1, 3, 5, 6. 1, 3, 5, 6. Right. Now in step 1, what I'll be doing is like, step 1, take this class and find the transition. Right. Take the class and find the transition. So first class is 2. Right. In this class my first state is 2. 2 comma, here you can write your sigma. Sigma is, you have only A and B. Right. So you have A and B. So this is your sigma. So 2 comma, my first alphabet is A. Right. So you have to check when state 2, when it takes A input, where it is moving 3. So you write 3 is in which class? 1, 3, 5, 6. This complete class you can write. While writing the class, you write inside your square bracket. Right. So 1, 3, 5, 6. This complete thing I'll put inside a parenthesis. Right. Next is for the same state for next alphabet B. Right. 2 comma B. Check 2 when it takes B input, where it is moving to 6. 6 is in which class? 1, 3, 5, 6. So I'll write my class 1, 3, 5, 6. Next 4. 4 comma A. 4. When it takes A, it is moving to 6. So it is, class is 1, 3, 5, 6. Next 4 comma B. 4 B. 4, it is taking B input and it is moving to 5. This is the class. 1, 3, 5, 6. Correct. Now you check. This 2 and 4 belongs to the same class. Now in minimizing this DFSM, right, minimizing is what? I'll reduce the number of states. Right, I'll reduce the number of states. If the states, when it take input, right, if it is moving to final state or it should move to non-final state. Right. If it is moving all the states in a class, all the states, if it is moving either to final state or non-final state, it is equivalent class. Right. Equivalent class means no need to, it is equal. Right. No need to write it separately. I can write it together. Instead of writing 2 and 4 as a separate class, I can write as a single class. Right, when I can say a class is equivalent, right? When it takes input, it should move both the states. It should move either to final state or non-final state. In that case I can say a class is equivalent. Now you see 2 and 4, when it takes 2 and 4, when it takes A input, it is moving to non-final. Similarly, when it takes B input, it is moving to non-final class, right? So I can say it is equivalent, so no need to split. So just you write the command splitting not required. When I should split? When it is not equivalent, I should split it. When it is equivalent, no need to split, right? So in just you have to write the step command. Now do for the next term, non-final class, right? So 1 comma A, 1 A, right? 1 when it takes A, it is moving to 2. 2 belongs to which class? Final class. 2 comma 4, right? Next 1 comma B, 1 B, again it is 4, class is 2 comma 4. Next 3 comma A, 3 A, it is moving to 2, so 2 comma 4. 3 B, 3B, it is moving to 4, so class is 2 comma 4. Next 5 comma A, 5 A, it is moving to 2, class is 2 comma 4. Next 5B, 5B, 4, so it is 2 comma 4. Next is 6 comma A, 6, so it is class is 1 3 5 6. Next 6B, 6B, again it is 1 3 5 6. Now you check, right? 1 when it takes A input, it is moving to final. Similarly 3 it is moving to final, 5 it is moving to final. 1 state when it takes B input, it is moving to final. 2 when it takes B input, moving to final. 5 it is moving to final, but this 6 it is moving to non-final. So here I should write splitting required, right? In step 1 I had only 2 classes, both the classes I have completed. Now you can split. So for this 2 comma 4 I have written the command as splitting not required, so don't split it. But for this non-final class I have written splitting required, so you have to split it. When you split it, you have to make this 6 separate and this 3 you have to put it in a single class, right? So here I'll write 2 comma 4 as it is, right? Since splitting not required, here I'll write 1 3 5 in one class and 6 I'll split it, right? Next is step 2, right? In step 2, these are my classes. For this classes I have to repeat these steps. This procedure I have to repeat for this class. Initial classes were this one, I have done the procedure. Now my class is this one. I have 3 classes. For this I have to do the same procedure, right? Now 2 comma 2 when it takes A input, right? 2 when it takes A input, it is moving to 3. Now 3 is in which class? This class. So it is 1 3 5. Correct? Next 2B. 2 when it takes B input, 2 when it takes B input, it is moving to 6. Now my 6 is separate. 6. Correct? Next, in this class 2 is over. Now I have to do for 4. So 4 comma A. 4A. 4, when it takes A input, it is moving to 6. Right? 4, when it takes A input, it is moving to 6. 6, it is in separate class. I'll write as it is. Next 4B. 4B. Where is 4 here? 4, when it takes B input, it is moving to 5. So it is 1, 3, 5. Now you check for A, 2, when it takes A input, it is moving to 135 class. Here it is moving to 6. Right? Here it is moving to 6. Here it is moving to 135. It is not same. It is different. So I'll write the command as splitting required. Correct? You should write the command, but at the end of step 2 only, you have to split it. But you should not split now. You have to complete all the classes. Then you go for splitting. But at this stage, you have to write only the command. Right? Next it is next class 135. Right? So I'll write 1 comma A, 1 comma B. Similarly 3 comma A, 3 comma B. Next 5 comma A, 5 comma B. Okay, I'll check. 1 comma A. 1, when it takes A input, it is moving to 2. 2 belongs to which class? 2 comma 4. So I'll write the class 2 comma 4. Correct? Yeah. Next 1B. 1, when it takes B input, B, it is moving to 4. 2 comma 4. Correct? Next 3. 3, it is taking A input and it is moving to 2. Right? So class is, where do I have my class? Here. 2 comma 4. Next 3B. 3, it is taking B input and coming to 4. 4 is in which class? 2 comma 4. 2 comma 4. Next 5. 5, it is taking A input. 5, it is taking A input and it is moving to 2. So 2 belongs to 2 comma 4 class. I'll write the class. Next 5. 5, it takes B and it is moving to 4. Right? So 4 belongs to 2 comma 4 class. 2 comma 4. Right? So this 135 class is over 135. Right? Check, everything is same. So no need to split. Write the command splitting not required. Right? Next 6 is alone only. No need to check. Right? Now you can finish this step 2. Right? All the classes are over. All the classes are over. And now I'll do the splitting. For this 2 comma 4, I have written the command as splitting required. So I'll split it. 2 comma 4. This 135, I have written the command as no need to split. Sorry, I have to split. Right? So no need to split. And this 6 is already splitted. Right? Now how many classes I have? 2, 4, 1, 3, 5, 6. Right? Now, right, I have to check. See, 2 is splitted, 4 is splitted, it is alone, 6 also, it is a single state in a class. Now I have to check only this, whether I should split or not, whether this class can be splitted or not. So what will I do? My classes are 2, 4, right, 2, 4, 1, 3, 5 and 6. I'll start my step 3. No need to check these three classes 2, 4 and 6 because it is already splitted. I have to check only this one. So I'll write 1 comma A, 1 comma B. Similarly 3 comma A, 3 comma B and 5 comma A, 5 comma B. Right. So you can check 1 when it takes A input it is moving to 2. Right. Now 2 it is alone. Correct? Yeah. Next 1 when it takes B input it is coming to 4. So 4 alone. Similarly 3 when it takes A input, 3 A input it is coming to 2. 3 A input it is coming to 3 A input it is coming to 2. 3 B input 3 B input it is coming to 4. Right. Next 5 A input 5 A input it is coming to 2. 5 B input 5 B it is coming to 4. Correct. Now check all A transition it is moving to 2, all B transition it is moving to 2. What command I should write? Splitting not required. Splitting not required. Right. Now I have to write my minimized transition diagram. Right. So my final classes are 2, 4, 6 and 1, 3, 5. Right. Now you can write 1, 3, 5 together. Right. Next is 2. I'll write next I'll write my 4 and 6. See the diagram? Which is the start state? 1. So here you could see, yeah, 1 is the start state. Right. So where do I have this one? This class. So this will be my start state. Right. And check your question. Final states are 2 and 4. Right. So both 2 and 4 should be your final state here also. Right. So I'll mark as double circle. Right. Now you can check. Since all these 3 states 1, 3 and 5 are equal, you can take any one of the state and check the A transition and B transition. Right. What is the meaning? What we are doing in this question, we are minimizing the DFA. While minimizing equal states, I'll keep together. Not equal states, I'll split it. Right. So if I could not split 1, 3, 5 means it represents all these 3 states are equal. Right. So any one state you can take, either you can take 1, 3 or 5. Right. And find the transition for both the alphabets A and B. Right. So I'll take 1 A. When one state takes A input, it is moving to 2. Right. So it is moving to, for A input, it is moving to 2. Right. This is how I am supposed to mark the edges. Right. Similarly 1B. One state when it takes B input, it is moving to 4. Okay. So 1 when it takes B input, it is moving to 4. Okay, for this class, A input is over, B input is over. Now coming to this class, 2. You have to find the transition of 2, A and 2, B. 2 comma a, 2 comma a, it is moving to 3. 3, where do I have this 3? Here. So 2 comma a, 2 comma a, it is moving to 3. Then I have to find 2 comma b, 2 comma b. 2, when it takes b input, it is moving to 6. Right? So 2, when it takes b input, it is moving to 6. Right? Next I have to find 4 comma a and 4 comma b. 4 comma a, 4 comma a, it is moving to 6. 4 comma a, it is moving to 6. Next 4 comma b, 4 comma b, it is moving to 5. 4, when it takes b, it is moving to 5. Where do I have my 5 here? Right, so 4, when it takes b input, it is moving to 5. 5 belongs to this class. Right. Next I have to find 6 comma a and 6 comma b. 6 comma a, both a and b staying in the, it is a self loop. So here a comma b. Right. So this is my minimized DFA. So initially in the question, how many states I had? 1, 2, 3, 4, 5, 6. Right. After minimizing, how many states I have? I have only 4. Right. Thank you.